all trying to use the permutation. It just wasn't the right time. But today we're going to use the permutation because we need to. Today we're going to use it because we need to. So, permutations. What's the very first word you guys see and some of you remember from last year? Order. Order is important. Order is important, but is it maybe a good idea to say something like, without repetition? Oh, I could have said that. We'll say without repeats, and I can fit it right up there. Nice and pretty. Shoot, shoot. Okay. Yesterday, what we were seeing is that numbers could be repeated, letters could be repeated. Because it wasn't like a finite number of letters in the sense of Scrabble tiles, you only have so many. But we were talking about the entire alphabet, and it could be used multiple times, etc. Same thing with the computer generating the numbers. It has like a restriction between this and this, but it can generate the same number over and over again if it wants to. Or if chances allow. Or with license plates, we could have used the same number over again. We could have used the same letter over again, theoretically. Be a kind of lame license plate, but hey, why not? It's an option. Depending on, like, the different states, I'm sure, have different restrictions, and some states don't have to have any restrictions. Or try to have as few as possible to have as many license plates as possible. But like North Dakota, they can put on as many restrictions as they want. They don't need that many. At least I don't think so. Is there like a housing boom in North Dakota? Although I guess they probably the ones that are there have big families. I don't know. I'm just making up stuff. Okay, so then coming back. Ordering is important. Without repeats. If it allows repeats, if there are repeats, I would say fundamental counting principle is almost always the best way to go. Almost always. So kiddos, down below, how is this example with the letters A, B, C, D, E, and F different than yesterday, how or when we did the alphabet and we said, hey, where was that, by the way, the two-letter word? How is it different from this one, different pairs of letters from the English alphabet? Pairs, A. B, what letters were legal to use in this one? All the letters. And question, was this like a countable? Were we only allowed to use each letter once? No, we were allowed to use it. Yeah, well, only two letters. We were allowed to use them twice. We were allowed to repeat. And so that's why fundamental counting principle is good here. But what's the example saying here that says, hey, let's use a permutation instead? It says only use the letters, A, B, C, D, E, and F. And it says permutations, which means arrangements. So whenever you're thinking about arrangements, you have to think about them kind of like little Scrabble tiles. You know what I mean? You have the letter A, the letter B, the letter C, one copy of each. How many ways can you, if these were written on tiles on your desk, how many ways could you arrange them? Does that make sense? Quite a few. We can actually still use the fundamental counting principle, but just no repeats, which means how many options are there for how many could go in the first letter spot? You know what I mean? Six. 6, right? A, B, C, D, E, and F. But you just placed a tile. How many tiles do you have left that could go in the second spot? 5. So permutations, there's some sort of counting down. That's what I was trying to explain to some of you guys yesterday. There are 30 different permutations, 30 different ways. We'll say 30 different perms, and not the old hairstyle.
There's only you're only doing 2 letters.
Only 2 letters.
Oh, so you're doing all stuff.
Oh, sorry. I'm solving the problem I was going to write in down below. Shh. You're arranging all the letters. Thank you, thank you, thank you. They did not specify only 2 letters. I apologize. That was my next example that I was supposed to write down. Sorry. 3rd, 4th, 5th, 6th. So how many letters would you have after placing 2 tiles?
4.
Then?
3.
Then?
2.
Then?
1.
Hey, that's the same thing as what? 6 factorial. How would we write this in permutations? We would say, permutations, we have 6 objects, countable objects. They're not like repeats from some sort of, I don't know, category that we could go ahead and pull in, like the license plates, like the pairs of letters from the alphabet. 6 countable objects, 6 letters, and we're choosing how many of them?
2, 6.
Choosing? How many are we using? Is that a better way of saying it?
6.
6 choosing or using 6. We're using all 6 of them, so we would say 6p6. Guys, either way, whether you do the fundamental counting principle or whether you use the formula, is anybody trying it in their calculator to double check we're right? We get 720. So whether you do 6 factorial using the fundamental counting principle, or whether you do 6p6, you get the exact same answer. So there is a little bit of overlap between the fundamental counting principle and permutations. But first of all, before I do that example that I was saying, which technically we would say how many 2-letter words, this would be the example I was doing a second ago. 2-letter words, I'm going to put that in quotation marks because I'm not saying actual words, I'm saying like how many 2-letter arrangements could you make? Not combinations. Order matters. But that's the same idea. Permutations. How many 2-letter permutations could we make? Uh-oh. He got lost. But before we answer that question, why is it a permutation, kiddos? Not a combination? What's true if we're putting letters down in different orders? Is this too hard? Order is important. Order matters. You guys know that when you read. Many different words can have the exact same letters, but mean very different things when they're arranged different ways. Same thing with music, right? 2 songs could have the exact same notes. When they're arranged, arrangement, that's a thing in music. When they're arranged a different way, that's a very different song. True? If you get something from IKEA, has anybody ever shopped at IKEA? Okay, when you get it and you open the box, can you put all the things that are in there together in many different ways?
Well,
You can.
they all serve the same purpose. So.
Yeah, but depending on how you put them together, because you get very different results. Some of your parents have gotten very frustrated trying to put together whatever they've gotten. Usually it works out.
It's always IKEA's fault.
Okay, so question. They're cheap for a reason, which I appreciate, but just saying. How would we do, or what would we change for 2-letter words? You guys already saw me say, what if we're only choosing 2 letters? 1 and then 2. We already saw it be 6 and 5 and 30 different permutations. But question, kiddos, how would that look using NPR? Not National Public Radio.
6 and 2? No, 2 and 6. 6 and 2.
You have 6 total, and you're only using 2 of them. Does that make sense? Fundamental counting principle is possible. Permutation is possible. Now question, before we go see a formula for permutation, because I don't think we've done a formula at all yet, right? Okay. Before we do a formula, what formula would let 6p6 be 720 and 6p2 be 30 permutations? Because if you look at the top one, you might just think, oh, it's just 6 factorial. But then we look down here and say, but that's not 6 factorial. But doesn't it look like 6 factorial? What was taken away from that 6 factorial? 4, 3, 2, 1. 4, 3, 2, 1 has gone away, right? So 4 factorial. And Tyler's trying to go ahead and figure out what the actual formula is. And he's like, wait a minute. So if that's n and that's r, kind of like NCR that we've already looked at, could an NPR be n factorial over 6 minus 2 is 4, right? Nope, no r factorial. That's how it's different than combinations. There is no extra piece. But that's okay. Let's write it down and get it. That way we know it for sure. This first formula says if we're using all of them. The first one is like 6 letter tiles, using all 6 of the letters. We could just kind of have a shortcut and say, hey, anytime we have n elements and we're arranging all n, there's going to be n factorial different arrangements. But as soon as we say, hey, we have n objects, but we're only trying to use 2 or 3 or this or that or the other, well, then the arrangements or the formula, the way of solving the permutation is using n to r. Which technically, the first one could be summarized in the second one. So the second one is the most important one to memorize. That's the one I'm going to highlight and say, hey, this is the main idea. Because on the last page, if we did 6p6, it'd be 6 factorial over 6 minus 6 factorial, which is 0 factorial, which is 1. So, if n and r are the same, you will end up with the n factorial that the top one is trying to say. Are these spelling differences? I know a few people turn them in later. I don't know. I have 4 spirals up here. If they're yours, grab them on the way out today, okay? A little piece of one. As you guys finish writing the formulas, check out the example down below having to do with batting orders. People that play or enjoy or know anything about baseball. Can a different batting order produce a very different result? Did you say touchdown? Make it quick. A different batting order can definitely produce a different result. So the arrangement is very important. Same thing if you were trying to pick positions for a team, it's not just the team itself, but actually where the positions are. If you put people in different positions, once again, that could totally change the outcome, right? So batting orders, what are we doing? A baseball coach creating a 9-player batting order, selecting from a team of 15. Is it just going to be 15 factorial?
No.
Nope. How about 9 factorial? Nope. Why do we have to use NPR? I'm choosing fewer than I have. I'm not using all of them. So kiddos, how have we set it up? Why is it a P? Permutation order is important. What's my N? What's my total? From 15 that are on the team, how many am I going to put, or how many is the coach choosing for the batting order? 9. Could you plug into your calculator? Of course.
Yes.
Go to math, go over to probe. So, a couple of you head over there, that way you can check our answer, but the rest of us, let's do factorials. Because, what do you have to do? What if you have to do it by hand? What's on top? What's on bottom? Subtract. Good. 15 factorial over 6 factorial, and if you guys have been tracking, that's going to end up being 15 times 14 times 13. Uh-oh. Hopefully this isn't by hand. Times 11 times 10. Struggle. I have to keep on going until I get down to what? 7, then I stop, because 6, 5, 4, 3, 2, 1 gets canceled out. So my people in their calculators, calculatrices, calculators. What'd you get?
181621440.
Double check and have it.
One more zero.
What the heck?
Is that better?
Yeah.
That's kind of big.
Just a touch.
You know, in the trillions. Anybody double check?
No, it's
Do you agree?
billions.
No.
Oh yeah, it is billions. That wasn't even count.
Oh, yeah.
Billions, not trillions. Lame. Not enough
Okay.
options.
Still a pretty big country.
That's right. You could go to that one game.
That baseball coach is doing some real math.
Okay, now pause. Why on earth, if this is something where it's like, of course we'd be able to use our calculator, that's ridiculous. Why do you think you want to study this?
Because it's going to be non-calculator section of the test.
Maybe.
Jars
Or maybe it'll be something like the one we just took where I was like, okay, have it out, but fill in some blanks for me for Okay, make sense? Ready, set, and go.
What?
We've learned permutations, that's great and all. But does anything happen if we have, like, I don't know, you're doing your Scrabble tiles and you get more than one letter, words with friends, and you get B, 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 T, T, T. Yeah, it's gonna be awful.
It's
Right?
a pain, isn't it?
It's awful. Because your choices just went down, right? Your options just got limited, restricted. As we go to the dictionary, just start searching different things, being like, please something like, or start finding the cheats online. Anyway, because your options are limited. But how can we do that with the permutation? Because the permutation says, no big dealio, count up your letters as you guys are writing. 1, 2, 3, 4, 5, 6, 7, 8. The B's and the T's, there are 8 letters total. And if we're trying to arrange them all, figure out how many different ways of arranging them, say on your Scrabble thingamabob, in order to hopefully, sometimes it's like rearrange them, maybe it'll look better and I'll think of something better. Permutations would say no big deal, 8p8, and that ends up being 8 factorial. The question, are there truly 8 factorial different, distinct, different from each other arrangements? No. So what do we do? The long story short of this little formula up above, which is good and all, but to be honest, I think an example is actually a bit better for knowing how to do or how to deal with repeated objects that we're trying to arrange. Is to think of the idea. Kiddos, how many different rearrangements would permutations say that I could make of B and B and B? 3 factorial, right? Permutations say take those 3 B's and there are 3 factorial, 27 different ways of arranging B, B, B. But in the long story short, it's the same every single time, right? Now if we had like a yellow and a blue and a red and if it made a difference, I don't know. Like Rubik's Cube or something. But we're not talking about numbers and we're not talking about colors, so then coming back to letters. B and B and B arranged 27 different ways is not going to make a difference. Even if one has a scratch and one has a dent and one has part of its corner missing, I don't care. It's still B and B and B, right? So we need to take away all of those. When we divide, we get to reduce from above. And then, how many arrangements of T and T and T and T and T? Would permutations say there are? 5 factorial, right? But if I rearrange T and T and T and T and T, I think I did it right. Doesn't matter. So we need to take away all of those arrangements. See what I mean? So let's see if that formula up above makes a little more sense. You guys see it? So if you are arranging objects and if there are repeats and if you are choosing all of them, you can do n factorial over, and these little n1s, n2s, n3s are talking about basically the number of repeats. I'll just say n sub, what's a good letter for a number? A, can I say A? The number of repeated, each repeated object. Meaning, how many B's do we have?
3.
My grammar is awful. Let me get rid of the S. Yeah, so then divide by 3 factorial. How many T's do we have? 5. So divide by 5 factorial. So how about in the one below? Algebra. Algebra. Any repeats? Yeah, we have A and A, right? So then we're going to have our, how many letters? 1, 2, 3, 4, 5, 6, 7? We're going to do 7p7 because we're using all of them or arranging all of them. What am I going to divide by? How many A's are there?
2.
Exactly. Does that make sense? Good factorial, Caleb. So then we end up with 7 factorial over 2 factorial. Guys, I'm not simplifying because I trust that we know to go into our calculator, right? Not go over the probability. Now, what if I was to change this up just a little bit? Bless you, what if I was to say of something, bless you. To the effect of. How many 3-letter words? I'm going to put it in quotation marks because we're just thinking arrangements. Are possible using the letters below. I guess I could do a word like Mississippi, but that's in your homework. So let me do something else. We'll say you get
No,
do I think I have too many letters. And then we'll do another T. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. You just picked out tile, that's what you got. You're like, ooh, at least it's a Q and a U, and then I'm sunk. Too bad there wasn't an A, you could do, or an I, you could do quaint. Anyway, there's an I on the board, you can do quint. Maybe there are 2 E's, you can do queen. Anyway, come back.
You can do AAA.
If you get like a triple letter or something, that's like 50 points.
AAA counts in Scrabble or something.
Sure. 11%.
Not even close. Question! What are we going to do if there are only 3 letters that we're able to use or that we're trying to use? No, not 3 factorial. E for effort though.
It's 2 and then 8.
Remember, we're trying to do NPR over the number of repeats. So it'd be 8. No, we're only using 3. See what changes? So just because there's a little factorial up here doesn't always mean that's only trying to say, hey, when you have n objects and you're arranging all n, the better way of writing that would be NPR. Sometimes it's NPN, sometimes it's NP, a different number. Like in this case, we're only using 3 of them. And then on the bottom, 3 factorial is good, but you missed one. Good. You have 3 A's and you have 2 T's. Does that make sense? And if we were to plug and chug to our formula, it'd be technically 8 factorial. All over 8 minus 3 is 5 factorial. Ooh. All over 3 factorial, 2 factorial. That looks fun.
Awesome.
What's fun? And how would you simplify a complex fraction if you really, really wanted to before going to your calculator? Put it over 1 and say, I know how to do fractions. Multiply by the reciprocal. Anyway, long story short, go to your calculator, go to your calculator, go to your calculator. But I wanted to make sure that you guys knew what to do if there was an NPR that was involved with repeats as well. Alright, let's keep going. Ooh. So show off. Ready, set, go. I forgot I had this good example waiting. Couple more seconds. Do you guys get it? Maybe someone snazzy can go to their calculator and make sure they get it. Someone can back them up. We have a couple. Think about how many total letters, how many are we using, and are there any repeats? No other repeats, huh? What'd you guys end up getting?
55 over 3.
What would you plug in?
11 over 3.
Careful, 11p3, right?
And then 3 factorial. Oh, shoot.
3 factorial, that's good, but you're not done.
2 factorial.
You have to get, yeah. You have to count for the O's and the S's. Gotta be careful.
Okay.
Couple calculator people. Caleb's trying, Abby's trying.
5 over 2.
465 over 2?
165 over 2.
Oh. But we got that wrong. Does that sound right, Abby? That would technically be
Yeah,
what,
yeah.
82.5?
Yeah,
Yeah.
that's what I got.
Yeah, I don't know.
But how can you have 82 and a half?
Is probability an exact science?
But what? That makes no sense.
Is probability an exact science? We can double check it because this one actually isn't too bad to do by hand. You have 11 factorial all over 8 factorial.
Wait, so you can only make, if you did that by hand, you get 82.5.
You cut one of the pieces in half. Duh.
You would have 11, 10, 9, all over 3, 2, 1 times 2 times 1, right? And if you notice, that and that, that and that, aw, they're all odd numbers. Struggle.
Just do 55 times 3. What is that?
Mind-boggling.
60.
Combinations, last one. Combinations, last big idea. We talked about the fundamental count. Well, we talked about the whole, count up all the different possibilities and then find all the different possibilities and then count them up. We've talked about the fundamental counting principle, how you can make the blanks and use multiplication. We've talked about what to do if order is important or if order is not with permutations, combinations. But maybe we haven't really talked about what if order is not important, and that is where we are. If order is not important. The nice thing is, kiddos, this formula over here on the right, that's not a new one, is it? Over here? Yeah, it's the same one that we talked about with the binomial theorem, which does apply to probability, but we're not in that section yet. That's next section. But the last one, or I should say the previous formula, the one on the left, they're the same thing, huh? They're the same thing, huh? How does that work? Kiddos, if we were talking about cards for a second, and I'm not going to go too crazy if you guys want to talk to Mr. Che. He is not teaching kids how to gamble. I'm not exactly sure. But, anyway, his probability. He's not. That's what he came in and reminded me that he's truly not doing. You can go talk to him about how to actually play the cards. But coming back, he's teaching blackjack.
I love that.
But coming back, you love that game. But coming back, you guys have seen before, or if not, you'll see in section 9.7 something about what's the probability of picking a card from a deck and getting an ace, for instance. What would you guys say? How many ways can you get an ace out of a standard deck of cards? All the cards are there, the jokers are not inside. Okay, 4 aces, and then in probability, section 9.7 will take those 4 possible aces in that deck, as long as someone hasn't rigged it somehow, over, some of you know there are 52 cards in the standard deck, no jokers, right? So it'd be 4 out of 52. What if we said something about choosing an ace, and then choosing, holding the ace in your hand, and then choosing, I don't know, what else would you want after an ace? It all depends on the suit. Another ace. Sure, we'll say another ace just to be simple, because we don't know what suit, we don't want to go into all that. So, the probability of choosing an ace and then another ace. Okay, so first it was 4 out of 52, and that's going to be multiplication, we'll learn next section. What would be the chances of getting another ace? 3 out of 51, because there are only 3 aces left, and then you have 51 cards. How are them odds? Bad. But what if we were talking about your hand of cards? your hand of cards. If we were choosing one ace and then another ace, that would be a permutation in the sense of, hey, the arrangements matter as to which ace you get each time. It's a different way if you get like an ace of spades and then an ace of clubs, or an ace of clubs and an ace of spades. Still the same result that you want, but technically it's a different order of getting the cards. But question, what if we were talking about what's in your hand? Does it really matter when you got it if you're just trying to say, like, hey, what hand do you have? No. That's a combination. However, if we were to use a permutation would say, hey, those 5 cards, if you like rearrange them in your hand a different way, ooh, it's a new hand. No, it's not. It's the same hand, right? And if you arrange those a different way, oh, hey, it's a new hand. And you're like, no, it's not. It's the same hand. I'm just putting them in a different order. Doesn't that sound an awful lot like this repetition-y thing? Permutations would say, hey, rearrange these lots of different ways, and they're all different arrangements. And we said, no, they're not. We know better. Same thing with combinations. So, how do combinations work? Very similarly to repetitions. They say, take NPR, and those are all different number of arrangements. But, hey, once you have, for instance, a hand, or once you have a committee, or once you have students in a classroom, the arrangement of them doesn't make a difference to us. How does that apply? We need to divide by R factorial, or divide by, if it makes a little more sense, you take NPR and say, hey, those different arrangements are good, but divide by RPR, because you're like, wait a minute, but once you have one set collection of objects, of people, of cards, I don't care what arrangements they are in. So how does that apply to this committee down below? If we're talking about making a 6-member research committee, having 1 admin, 3 faculty, and 2 students, and we're choosing from 7 admins, 12 faculty members, and 20 students in contention for the committee. How many 6-member committees are possible? At the end of the day, do we care what order they're chosen, or what order they're listed as, like, these are the winners, or what order they're sitting in the chairs in the room having a committee meeting? No. We care who's on it, right? So this is an example of order not being important, or an example of combination. So then going back to what we said the other day about combination pizzas and locker combinations, which one is mathematically accurate? A combination pizza. If you order, like I said the other day, a sausage pepperoni, and the person in the back's like, meh, puts the pepperonis first, then the sausages, are you going to know the difference?
Yes.
Probably not. You're like, oh, my pizza, it's here. It doesn't matter the order, right? But if you go to your locker and you put in, I don't know, 23, and then you go back to 17, and it was supposed to be 17, then 23, you're going to have some issues. Magic. Locker permutation, combination pizza. One of them is mathematically accurate, one of them is not. So kiddos, on this one, we still kind of have to think about this in 3 different cases because we're choosing 3 different groups of people, right? We're choosing, let's see, 1 admin. So we're choosing an admin. We'll just say from administration. We're choosing from faculty. And we're choosing from students. Now, for the admin, see how I separated it in 3 different cases, but we're doing each of them. So we're doing the one and the other, multiplication, multiplication. For admin, how many total admin are possible? What are we choosing from?
7.
We're choosing 1.
7 NCO,
But we have 7 possible, right? Okay, so what are we going to put? Does that make sense? How many different ways? Now, do you guys know what that's going to be? 7. Okay. Plug it in the formula. You are right. Now, for faculty, what are we going to do? We're choosing 3 out of 12, right? We're getting 3 out of 12. So how many different ways can we choose 3 from the 12? We don't care the order that the names are listed. We're just caring about the people that are chosen. Combination, not permutation. And last but not least, because we had 12 faculty members and we were choosing 3. What's the last one?
20 NCR2.
20 students choosing 2. Does that make sense, kiddos? Now, in your calculator, when you guys go to plug in, you probably use this in binomial theorem a couple times. Remember, when you do NCR, what should you have typed first? The N, yeah, it just saves time. type the N7, then go use the NCR button. It's going to literally just put NCR, then you put the R button, hit enter. Can you, in your calculator, write these separately and just put little timeses in between? Yeah, saves time, so you don't have to do them separately. You guys are checking. I'm just going ahead and quickly putting it up for kiddos that don't have their calculators. Does anybody have how many different committees are possible? Almost. I'm almost there too.
2, 9, 2, 6, 7.
So you guys, we're in this menu. The factorial's chilling, the NPR's chilling, the 3 NCR's chilling. That's cool and all. Ooh, but I don't want it there. That's not going to help. But see how it just types the NCR? Put that N in first, then go ahead and go find it. I wish there was a shortcut to this one, but there's not. But we can go ahead and attach different NCRs together. We can go ahead and get math. Caleb, I heard your answer. I'm just going ahead and showing and double checking, and hopefully we have the same one. 12, 3, C3, and 20. C2. Same answer? Once again, definitely not by hand, but do we need to know the NCR formula for our quiz on probability? Yes. All right, cool kids. This is the end of section 9.6, homework 58, due tomorrow. Have I updated the board? Oh, I just didn't put due tomorrow. Our goal was to finish section 9.6, but here's the dealio. We have a probability quiz next Tuesday. Probability quiz next Tuesday. We've done 9.6 for a couple days now. We have just a few minutes of class left. Let's go ahead and just get the beginning of notes for 9.7 done. And the cool thing is, you guys are awesome. You already did a 9.7 problem with the whole picking of cards, aces. Dealio. So if you want, you can sort of, in a very probably non-realistic sense, pretend like you're doing math homework tonight and play some like solitaire, blackjack, or hearts or something. But not for long. Don't get addicted.
Get addicted to system here.
We'll go here. I have a couple things in notes just to go over a couple common homework questions tomorrow with section 9.6. Maybe you'll need it, maybe you won't. But 9.6 kiddos, if you haven't started it yet, you're just going to get big numbers. You're just going to be counting up how many ways can this possibly happen. 9.7 says, what are the chances that will happen and not something else? 9.6 says, how many ways can we count up that something, a favorable outcome is the way we technically refer to it, can occur. 9.7 says, all right, cool, but what are the chances that actually happens?
Not great.
Chances, that's like a percentage, right? Percentages, those are like from decimals, right? Decimals, don't they come from fractions? So probability, it kind of makes sense. Its formula would be a fraction. The number of ways something can happen, sometimes really big, but probability is sometimes really small because the total possible outcomes were bigger. Tyler.
How many sections are there in 9B?
Just 9.6, 9.7, that's it. So we're finishing 9.6 tonight, and then 9.7 will be, or today, sorry, you're finishing it tonight in homework. 9.7 will be today, just a little bit, tomorrow, maybe a little bit on Monday. Monday will be half finishing 9.7, half reviewing, probably going over homework questions too.
So are we gonna turn in our homework on Tuesday?
Yeah, just 9.6, 9.7 though. There might be a little baby probability review.
There's only 2 homework assignments. We can do both on Monday.
I mean, both tonight. What?
Don't do both tonight, that's silly. Do 9.6 tonight, like you're supposed to. Anyway,
Okay, alright, I'll do it.
and then remember on Tuesday it's a quiz, not a test, but I'm still grading homework. I might not grade notes, it's 2 sections. Maybe I'll grade notes.
Okay.
Kiddos, you see a couple terms, but the nice thing is we've used one of them over and over again, right? And I kind of use the idea of what is describing probability up above, the chances of a favorable outcome occurring. Chances, decimals from fractions, small numbers. Big percentages, perhaps, but small numbers.
When's the National Day of Prayer?
I don't know. Isn't that in May?
Oh, it's in May.
I think it's in May.
We come in
It's like
late.
the first week of APs usually.
We come in
Maybe it's the
late,
week
right?
before. It's a late start, yeah. Not a non-con.
9:30.
Something. You know better than I do. Outcomes. I just work here. Outcomes. Same. We've already talked about this. Kiddos, are outcomes what actually happens?
No.
Not necessarily.
Hopefully.
Outcomes are really what could happen, right? What could occur. Favorable outcomes, a certain condition is actually being met. Total outcomes, well, hold on, sample space. Sample space is the accumulation of the total number of outcomes for a certain scenario, a certain event. Whether it's picking cards, whether it's raining or not outside, whether it's forming a committee, making a seating chart, picking marbles out of the bag, whatever example you want to use. Total number of outcomes, the favorable and the non-favorable. Unfavorable? Come on, my writers out there, which one's better? Unfavorable. Non-favorable? Unfavorable? Okay. That was an awkward space. Good thing I have a program. Oh, I just stole an E. Okay. So, question. If probability is equal to the number of ways a certain event or the number of favorable outcomes, whatever condition they're saying. And if n sub s is the number of total outcomes or the sample space, so you have the number of ways that the event can occur over the sample space number or the number of total outcomes, can probability ever be higher than 1?
No.
Why not?
Because then it's 100% chance.
Yeah. Probability equals 1 is 100% chance. Can probability ever be above 100% chance? No. So when speakers, we'll just say in general, sometimes preachers, sometimes motivational speakers or coaches, I want you to go out there and give 200%.
They're not mathematically correct.
They're not mathematically correct.
They should be killed.
Now, if you want your profits to be, yeah, no, we all disagree with what he just said. Thanks so much, Tyler.
Except for me.
Guys, on the video.
My correction of his statement. Coming back. Could you have 200% profit? Yeah, you could make more than you expect, but probability? No. Never above 1. So therefore, probabilities will always be between 0 and 1. 0 means it
No, it doesn't happen.
will not happen, cannot happen. 1 says it will for sure. Bye, cool kids. See you tomorrow.
All these videos are going to be used as evidence for his trial.
Okay, sounds good. What's the trial going to be?
Who knows?
Toilet says